So good morning everyone and welcome to the lecture. Lecture number 6. We are doing rotation on fixed axis, and in the previous class we were discussing this problem. What is the answer for this? Yes. What is the acceleration of the blocks and what is the angular acceleration of the pulley? Yes. Answers.
Sir, it is acceleration. Acceleration is m2 minus m1 into g by m2 plus m1 plus I by r square.
Good. And what is the angular acceleration?
M2 minus m1 by it is a into r, sir. Simply
A into R.
a by r. Sorry, a by r.
A by R. Good.
A into 1 by r.
So we understand that M2 block is moving down, M1 block is moving up, and for this to happen, your alpha should be like this. We understand this? Now, we have already written the two equations. This was equation number 1 and this was equation number 2. But what you see in these two equations are three unknowns and only two equations. So obviously, it cannot be solved. So I have to look for the third equation. What is the third equation? The first two equations come because of the translational motion of the bodies. The third equation will come because of the rotational motion of the pulley. What is the equation for rotational motion of the pulley? Torque for this pulley. Torque for this pulley should be equal to I into alpha. Now I is given, alpha is the angular acceleration. You just have to find out the torque. Now how will you find out the torque? This force is creating torque in this direction, yes or no? And this force is creating torque in this direction. Both are not adding up, they are getting subtracted, yes or no? So what is the net torque on this pulley? It will be T2 minus T1 into R, yes or no? T2 minus T1 into R, that must be equal to I alpha. That becomes my equation number 3. But again, the problem with this equation is I have introduced one more unknown, which is alpha. So now I have 3 equations, but I have 4 unknowns. That means I need one more equation. I somehow need an equation between alpha and A. Now, how will I get this equation between alpha and A? I will take 2 points, 1 point on this and 1 point on this. Do we remember this? I take 2 points, 1 point on the pulley and 1 point on the rope. Let me draw it here so that I can show it in a better way. So this is the pulley. I have taken 1 point on the pulley, point number 1, and 1 point on the rope, point number 2. You can take it on this side, you can take it on the other side, doesn't matter. This point is moving with an acceleration A and the pulley is moving with alpha. So alpha into R will be the acceleration of this point on the pulley. As you can see, there is no slipping between the point of the pulley and the rope. Therefore, these acceleration must be equal. So from there, I will get my fourth equation. What is my fourth equation? A will be equal to alpha R. We understand this? Now you can eliminate the two quantities, three quantities, four quantities, whatever they are, and you can get the value of A or alpha. I've already told you the way to eliminate it. Once you eliminate it, you will end up with the final result M2 minus M1 into G divided by M1 plus M2 plus I by R square. Do you understand this? Yes or no?
Yes.
Everyone got this answer? Now, if you look at this answer, when I say this answer, I mean this one. And you look at the answer that we got from the previous question. You can see a pattern in the two answers. What is the pattern? On the numerator, you have whatever force is trying to pull it down. And in the denominator, you have the mass of the body. Here, there was only one mass, so M. And then you have for the pulley I by R square. Now, if you understand this, you can get the answer for any question of this type. Don't have to solve them. If you understand it, you should get the answer straight away. How can you get the answer straight away? You can apply some common sense and get the answer for this one. Starting with question number 3 because it is a continuation of what we had done. Now let us say that I have this pulley here. I have this block. Let me call this as M2. And I have this block kept here M1. The moment of inertia of this pulley is I. The radius of this pulley is R. There is only one way this system is going to go. How is the system going to move? How is the system going to move? Which way the system is going to move? How is the system going to move?
M2 will move downwards and M1 will move right side.
Will the acceleration be same or different?
Same acceleration, yes, sir.
Same acceleration. How will the pulley rotate?
Clockwise, sir.
Pulley will rotate with alpha clockwise. Can you tell me the value of A and alpha? You have 2 minutes to do this. Yes, we are trying. Yes or no?
Sir, it's done, sir.
What is the answer, sir?
M2G by M1 plus M2 plus I by R square.
Hmm. Correct. How did you get it?
By solving, sir.
Huh?
By solving the equation, sir.
By solving the equation, sir. What are the equations that you made?
It marks M2 acceleration.
So you draw the free body diagram. This will be M2G. Let me call this tension as T2. Let me call this tension as T1. This will be T2. This will be T1. The first equation you will get will be T1 is equal to M1A. Yes or no?
Yes, sir.
Then you will get M2G minus T2 is equal to M2A. Then the third equation that you will get will be from the pulley. T2 minus T1 into R is equal to I alpha. Then you will get the slipping equation. A is equal to alpha R. You solve all these equations together, you will end up with the acceleration m2g upon m1 plus m2 plus I by R square. Yes or no? You did not have to do all this. You did not have to do all this. You could have just seen what we are doing from the previous things. The only force which is trying to pull it down is M2G. This M2G comes here. And the rest of the blocks, M1 and M2, come here. And for the pulley, you have I by R square. You do not have to do this. Now, if I take you back to Newton's laws of motion, in Newton's laws of motion, this pulley was not rotating. So this entire term disappeared. So this entire term will disappear. And the answer, when the pulley does not rotate, is M2G upon M1 plus M2. When the pulley starts to rotate, the answer becomes M2G upon M1 plus M2 plus I by R square. Do you understand what I'm saying? Do you understand what I'm saying, or is it gone? Okay. Let's see if you can do better with this one. Let me give you some values, otherwise you will not be able to do this because angle has come. This is 2 kg block. This is 6 kg block. The moment of inertia of this disc is, let us say, 5 kg meter square. Let us say the 5 kg meter square is the moment of inertia. Let us say the radius is 1 meter. Can you now tell me the answer for the acceleration? We have 2 minutes to do this. Yes, bacha, any answers? Huh?
Sir, it's 10 by 13, sir.
Okay, I have to calculate. How did you get 10 by 13? Just tell me. Oh,
Here,
here. First of all, you have to tell me which direction it is going to move. First of all.
2 kg's body is moving up and 6 kg body is moving towards ground, sir.
Okay. I give you that one. That is correct. Then what is the acceleration of the system? Yes.
There are, now only you said the logic, sir. Forces are due to the moving bodies, due to acceleration. So we have subtracted them both by adding all masses.
What is the pulling force?
Sir,
What is the force which is trying to pull it down? That is what I.
mg sin theta, sir.
Mistake. You still have 2 more minutes to do. Mistake. Think logically. Think logically. Think logically. Look at this question as your guide. What was your pulling force? Now go back to the same question. And now think. I'll give you 2 minutes to think. I know that you can do this, so I don't want to do it. I want you to do it so that you understand. Once you understand it this way, I think you will never forget it, what we have done. To understand it. Understand the pulling force. What is the pulling force? Oh, I should have not said pulling force. Net pulling force. What is the net pulling force?
Sir, it is mg sin theta minus that is 6g sin theta by 6g sin theta minus 2g, sir.
That is the net pulling force. Now you are correct. The force which is trying to pull it down, and I'm not drawing the complete diagram, the force which is trying to pull it down from this side is 6g, which is 60, into sine 30, which is half. So basically 30 newtons is trying to pull it from this side.
Yes, sir.
20 newtons is trying to pull it on this side. Who is going to win? 30 Newton is going to win. So the net pulling force, and I can now straight away write the acceleration. I don't have to write those equations. Net pulling force is 30 minus 20 divided by 2 plus 6 plus
5 by 1 square.
5 by 1 square. That is the answer. Now, if you just take this pulley off, that means this pulley does not rotate. This part will go up. This part will go and you will have your answers. Do we understand this? How are you supposed to do this? Can apply this wherever accelerations are same, one body is rotating. Wherever the accelerations are same, you can apply this. But you cannot apply this when the accelerations become different. Then you will have to go to the original method. Do we understand this? You can only apply this when what? When the accelerations of everything is same. If the accelerations become different, then the problem comes. Then you'll have to go to the original method. Chalo, then if you have done this, let me give you a fantastic question now. Let's see if you can do this one. Chalo, let me try this. I was not planning to do this, but there is no problem in trying it. Now I have this pulley. Now this pulley is a special pulley. It has a moment of inertia given as I, but now it has two radius, R1 and R2. There's two radius, R1 and R2. From here, I have attached a block M2, and from this side, I have attached a block M1. Now can you do this? This is rotation, my dear friend. No one understands it. But if you understand it, it creates some fascinating problems. You look at the problem, wow, what a problem. You look at the problem, you feel happy, wow, what a problem. But you'll only feel happy unless you do it. Let's see. I was not planning to do this, but since you have done this, you've understood something. Try this. You have 2 minutes to do this. Yes, my dear friends. Anyone? Any idea? The first question is, do the blocks move with the same acceleration? Hmm? Do the block move with the same acceleration? Yes or no? Huh? No, they don't move with the same acceleration because they are not attached to the same point in, same surface on the pulley. So they don't move with different, they don't move with same acceleration. The accelerations become different. Do I have the answer? Or shall I do it? I don't want to destroy the party. See, I can do it, but if I do it, then there is no point of giving the question. The point of the question is only justified when you solve it, not when I solve it. I solving it is not the right thing. I'll give you time. Don't worry. You can do it. I know. There's nothing different in this question. The only thing, police has got different radius. That doesn't make any difference. You know the original method of doing it. So if you apply that, you should be able to get it. Well, one thing is sure, if this the only way this system can move is this block has to go down and this block has to move forward. Yes or no? That is the only way the system can move. Yes or no? So this moves with an acceleration a1. This, oh sorry, this is 2. This moves with an acceleration a1, a2. This moves with an acceleration a1. You have 2 minutes, my dear friends. Or shall I do it? Huh? So then I'll solve it for you. I think you're stuck somewhere. Life is not about sticking. Life is about moving ahead in life. So this is M2G this is T2 ta na 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 T1 how is the pulley going to rotate? No problems to understand this. The pulley has to rotate like this alpha. That's it, my dear friends. We now start writing these equations. The first equation is T1 is equal to M1A1. No problems with this one. The second equation is equal to also keep on counting the number of unknowns and the number of equations that I have. M2G minus T2 is equal to M2A2. Oh, only two equations, but four unknowns. Don't worry. That comes the equation of the pulley. What is the equation of the pulley? Now here the radius are different, and that is why the equation of the pulley also starts to look different. T2 into R2 minus T1 into R1 will be equal to I into alpha. Do we get this? What next? Three equations, but five unknowns. Don't worry, you have got two more equations. What are the two more equations? A1 is alpha R1, A2 is alpha R2. Five equations, five unknowns. How are you going to solve it? I will leave it to you, because this is now a problem of maths rather than a problem of physics. This problem could have been made more easier if I had given you some relation between R1 and R2. If I had given you some relation between R1 and R2, this problem would have become simpler. So I will make it simpler for that so that you can solve it. Let me say that this is the most general problem. Now the problem with this problem is you will have to solve all these five equations. Obviously, this problem cannot come in JEE Main. This problem may come in JEE Advanced, but then again, you will have to solve five equations to get the answer. It will take some time. So if you encounter such problem, even if you know that you can do this, better you can just skip it in the beginning and move forward. Just to tell you how to solve it, let me give you a relation here. Let me say that, because you will have to solve it in the given time. Let me say that R2 is 2 times R1. Now it probably becomes easier to solve. Yes or no? Becomes a lot easier than it was looking before. We can now solve it. With this, how are you going to solve it? I'll tell you my way of solving it. If I would have solved this, there's only one quantity I feel which I can solve for and I can get the answer fastest, and that quantity here is alpha. So if I would have solved it, how would I would have solved it? Since I know that R2 is 2 times R1, this will be, or let us say 2 times R. So this will become 2 T2 into R. This will become T1 into R. Okay. Yes or no? Now, this equation will be in terms of alpha. Now, what I will do, I will convert A1 into alpha. I will convert A2 into alpha. Then I have T1 and T2. I can eliminate T1 and T2 and I will get the value of alpha, because A1 and A2 are already eliminated from these two equations. Then you have three equations. You have to eliminate T1 and T2. You can eliminate T1 and T2 and you can get the answer for alpha. Once you get the answer for alpha, you should be able to get the answer for A1 and A2. Do we understand this? So the problem with this problem is not with physics. The problem with this problem is with maths. How you can do it quickly? Physics does not create problems. It's maths that creates problem. Physics just gives you equation. If you can solve it, well done. If you can't, physics can't help you. Okay? Do we understand this? Yes or no? Shall we move ahead with different set of problems? See, as I keep on what? Keep on what? Keep on telling you that there are infinite number of problems which are possible in any topic in physics. There are infinite number of problems. In rotation, that becomes infinity raised to the power infinity, because I can make just infinite problems. Right? I can assure you that I can teach you rotation for 1 year continuously, 1 hour each, 1 hour every day. Still, I will not be short of problems. Still, I will have enough problems left. So, you'll have to just understand what types of problem can come. This type of problem which I showed you just now, even if it comes, you'll have to think whether you can solve it in the given time frame or not. Okay, now let us move on to the different set of problems. Now, before moving on to this different set of problems, let us first, we had done work energy theorem, yes or no? Now we can also see law of conservation of mechanical energy once more, because now I have rotation coming into the picture. So let us have a look at Lockmey once again. What does Lockmey say? Huh? Law of conservation of mechanical energy. If non-conservative forces are absent, or work done by non-conservative forces is equal to 0, then mechanical energy of the system remains constant. Do we understand this? Now, when I say mechanical energy, it means potential energy plus kinetic energy of the system remains constant. Now, when I say kinetic energy of the system, now this kinetic energy of the system can be of translational nature, it could be of rotational nature, it could be a combination of both translational and rotation. Do we understand this, or this has gone above our saying bye bye? Huh? Okay. Now we have seen this law of conservation of mechanical energy in pure translation. Now we got to see this law of conservation of mechanical energy in pure rotation. Let's start with the simplest possible problems. And again, as I told you, the number of problems that can be made are infinite, and I cannot go till infinity. This is the problem that I have. Oops. It's better to use this. I have a rod. Why did the rod disappear? Rod has reappeared. I have a rod of length L and mass M, and it is hinged at this point. Do you understand the meaning of hinge? Pinned at this point. Now it is at rest. It is lying horizontal like this, and I leave it. What will happen? What will happen? The rod will fall down. Yes or no? But it is hinged. When it reaches this point, vertical position, you have to find out the angular velocity of the rod. The rod is in horizontal position. Then I release it. Ping, 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 ping. It comes down. When it reaches the vertical position, what is the angular velocity of the rod? Everyone understand the question? Well, then the question is yours. And the time is also yours. You have 3 minutes to solve it. And I hope you can do a better job. Remember, the number of problems are infinite. I can only do a few, which I think can come. The previous problem that we did, even if it comes, remember that you will take time to solve it. So you have to selective. That is what I talk about rotation. You have to be very selective in selecting the problems. And this is true not only for rotation, but for mechanics in general. Yes. Any idea? No idea, get idea. Shall I do it for you, bacha? Huh? Should not take so long. Yes, Beja. Shall I do it?
Sir, it is 3G by 2L.
3G by 2L. That is correct. 3G by 2L is correct. Well done. How did you do it?
Sir, torque equals to I omega.
Torque is equal to I omega. Huh? Torque is I omega? Who said, who told you this? You got the correct answer, but I don't know how did you got it. How you got it? The answer is correct though. I must give you that. But how you got it? Torque is equal to I omega. Eh? So sometimes using wrong concept also, you end up with the right answer, and that is a very difficult and different and wrong condition. Okay. So how I am going to do this? Let us think about the forces acting on this rod. The one force which is acting is definitely the weight of the rod, which acts at the center of mass. Yes or no? Huh? Yes
Yes,
or
sir.
no? The other force is the force in the hinge. No. This force in the hinge is a variable force actually. But this rod is in pure rotation. Do we understand this? Yes or no?
Yes, sir.
And this force in the hinge is not rotating the rod because the rod is fixed about that point. It cannot create any torque, and the rod is not moving translationally. So this force in the hinge cannot do any work. Yes or no? Huh?
Yes, sir.
The only force which is doing any work, because of which this rod is moving down, is gravity. Yes or no, my dear friend?
Yes, sir.
Yes, sir. That is, sir. So when the rod goes like this, dung, 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 let me. So when the rod goes in its final position, the rod is in final position like this. The rod is in final position like this. It actually move. The weight actually moves in a circle. Yes or no? Like this. See, I've drawn such a beautiful diagram. The only force which has done any work, the only force which has done any work is your gravitational force. Yes or no? Yes or no?
Yes, sir.
That's it. Now I can apply the mother theorem or the daughter theorem, and I can get the answer for omega. What is the mother theorem? Mom theorem.
Work done by all forces equals to change in kinetic energy.
Good. You can apply that mother theorem. So what is the work done? There's only one force which is working, that is gravity. How much work that force has done? Let me apply the mother theorem. WET, work kinetic energy theorem, the mother theorem. Work done by all forces is equal to change in kinetic energy. Yes. Tell me what is the work done by all forces. There is only one force which is doing any work. Yes. What is that force? Huh? What is that force?
mg, sir.
Mg. How much work it has done? Hmm.
mg L by 2, sir.
Mg L by 2. Work done by gravity does not depend on path. You just see where is the initial position, where is the final position, find out the vertical distance. It is positive because gravity is downward. So mgl by 2. What is change in kinetic energy? Final kinetic energy. It does not have any transitional kinetic energy. Yes or no?
Yes, sir.
Only has rotational. What is the final kinetic energy? Half
I omega square.
I. I is ml square by 3. Yes or no?
Yes, sir.
Into omega square. What is the initial kinetic energy? Eh?
0, sir.
0, sir. That is your answer, sir. 3 G by L ka root. That is your answer. Omega is root over 3G by L. This is how I have done it by work energy theorem. I could have applied law of conservation of mechanical energy. It's the daughter theorem, so you can apply the daughter theorem. You can apply Locke-May. Now to apply Locke-May, total mechanical energy remains constant. You have to take some point whose mechanical energy, whose potential energy can be taken as 0. Let me take this lowest point. The potential energy of this lowest point is 0. Now remember, whenever we talk about potential energy in terms of rod, we have to look at the center of the mass of the rod, how much it has moved up and down. Yes or no? I told you that, right? We had found out the potential energy of this rod in this position, this position. Remember this? Huh?
Yes, sir.
Ah. So I take the potential energy of the lowest point as 0. Then the total mechanical energy should remain constant at the highest point. What is the mechanical energy? And the highest point, it only has potential energy. So that is mg plus mg into L by 2.
Yes, sir.
The kinetic energy is 0. At the lowest point, it only has kinetic energy. The potential energy is 0. You end up with the same equation no matter how you apply it. Do we understand this, or this has gone above everything? Bye bye. Bye bye. I have had enough of this. I'm going.
Yes,
Huh?
sir.
Understood?
Yes, sir.
Now we have the problem. We can find out the general answer. You can call this angle as theta, or let me not call this angle as theta. Now, when the rod is at an angle theta with the vertical, no, with the horizontal, what is the angular velocity of the rod? This is question number 2. This was when the rod was vertical. Now the rod is at an angle theta. Now, when you get the value in terms of theta, the problem becomes a general problem, because as soon as you put the value of theta as 0, it should give you the initial position. As soon as you put the value of theta as 90, you should get the answer of the final position. Do we understand this, or this has gone above our saying bye bye? Bye bye, going bye bye. So now the question is theirs, and I hope that you can give me a satisfactory answer. Remember, the questions are infinite. Yes, but any answers? Huh?
1 minute. Sir, it is omega equals to under root 3g sin theta by L, sir.
How did you get it?
Sir, I have applied work energy theorem.
Okay. So it comes at this point.
Yes, sir.
Yes or no?
Yes, sir.
So basically you have to just find how much is this height. Yes or no?
Yes, sir.
And how can you find out?
It is L by 2 sin theta, sir.
It is L by 2 sine theta, sir. That is correct, sir. That is correct, sir. So you just apply work energy theorem from the initial point A to the final point B. You can apply work energy theorem or you can apply Lockman, doesn't matter. What is the work done by gravitational force now?
mg L by 2 minus mg L by 2 into 1 minus sin theta.
Into 1 minus sine theta, why?
I have taken common, sir. It is now the height is L by 2 minus L by 2 sin theta, no, sir. With the reference line.
Okay. With the reference line you are saying, okay, mg L by 2 into 1 minus sine theta. That will be equal to?
Sir, it is not that, sir. mg L by 2 minus mg L by 2 minus mg L by 2 into 1 minus sin theta.
So at the end of the day, what will you end up with? You'll end up with this, right? I'm applying work energy theorem. So work done is mg L by 2 sine theta, yes or no?
Yes, sir.
That must be equal to half I omega square. And I is ml square by 3. Do we understand this?
Yes, sir.
Yes or no? Then we will do this one question as the last question in this category. You don't need to do anything more than this. If you're able to do this question, that means we can move ahead in life. This encompasses everything that could be asked. Let's see if you can give me the answer for this one. Remember, no one understands the rotation. No one. The best of the teachers who are taking class in best of the places, anywhere in the country or India or outside, in any universe, no one understands rotation. So if you're not able to do this, I might not able to do this, that does not make any difference to anyone's life. No one understands rotation. If I put a problem in front of any person in this universe, there is only a 5% chance that he will be able to solve it. Only a 5% chance for the person who knows everything. So remember, no one understands rotation. We can only try. And the number of problems that we try, there is a probability that the same type of problem will come, and then only we can do this. If a problem becomes somewhat different, it becomes difficult for anyone in this universe. Remember this. Is it a problem if you can do this? That means you've understood the entire concept and you don't have to do anything more further. A uniform rod of mass m and length L can rotate in a vertical plane about a smooth horizontal axis hinge at the point H. So you can see this is exactly the same scenario that we did. Find the angular acceleration alpha of the rod just after it is released from the horizontal position. Calculate the acceleration of point A at this moment. Calculate the next hinge force acting at the moment. Find out alpha and omega when the rod becomes vertical. Find the hinge force when the rod becomes vertical. So basically what they're asking, what we calculated, what only omega at different positions. They are just asking you to give the value of omega as well as alpha as well as the hinge force, because there is a force acting on the hinge. You have 2 minutes, 3 minutes, 4 minutes. Take your time, do it. If you're not able to do it, we'll do it in the next class. Don't worry. You can understand this. There's nothing left for us to do more in this particular section of problems. So you have 2 minutes to do this. Try it. If you can do even 1 or 2 sections of this on your own, that is an achievement in itself. Remember, no one understands rotation. Not me, not anyone else. Okay. Anyone? Shall I help you? Okay. Let me solve the first part and I'll give you the rest of the part as homework. Now this is the initial position. Yes or no?
Yes, sir.
The first point is you have to find out the angular acceleration alpha. Now there is only one force which is causing the angular acceleration. What is that force?
mg.
You can first find out the angular acceleration. What is the angular acceleration of the rod? You have to find out the torque. It is creating torque like this. Yes or no? How much is the torque? Torque will be equal to I alpha. Yes or no? How much is the torque this force is creating? Mg into the distance is L by 2 will be equal to ml square by 3 multiplied by alpha. Do we understand this?
Yes,
From
sir.
here, I can find out the value of alpha. The value of alpha, the angular acceleration, is going to come as 3g by L. 3g by 2L. Yes or no? Yes or no? Now you have to find out the acceleration, which consists of both tangential and radial of point A. Now you look at this point A. As I told you, there will be two types of acceleration. One would be the tangential acceleration AT, yes or no?
Yes, sir.
And the other one would be the normal acceleration AN. AN, yes or no?
Yes, sir.
You can easily find out both of them. Tell me the answer for both of them. What will be the tangential acceleration of this point? We had seen that equation in circular motion. Tangential acceleration is alpha multiplied by r. Yes or no?
Yes, sir.
So alpha is 3g by 12 multiplied by the distance of this point from the center of the circle. How much is that? It is equal to L. So the acceleration of this point becomes, the tangential acceleration becomes 3g by 2. Do we understand this?
Yes, sir.
Talking about the normal acceleration is equal to omega into r. Yes or no?
Yes, sir.
But it is released from rest. Yes or no? So
Yes,
this
sir.
becomes 0. The total acceleration becomes under root of at square plus an square. There is no an here. So the answer becomes 3g by 2. Do we understand this?
Yes, sir.
The three questions which are remaining are this, and I'll give you time to think about this. I think you can easily find out number 4, yes or no? Because we have already done one part of number 4.
Yes, sir.
You can find out alpha. 3 and 5 we will do when we come back in the next class. Okay? We might skip it we might skip it now, and probably we can do it later on. I will see how we are going to go about it. Do we understand this, yes or no? Chalo. Then I will wind up this class here. In next class, we'll probably move ahead and wind up this fixed axis definitely. And then we'll move on to the point which no one understands. When the axis is not fixed. As I told you, no one understands rotation. So take care. And you can only do very simple problems. This is a simple one. And only these problems are going to come. Trust me on that. A typical problem in rotation never comes because no one will be able to solve it. And if you get into that problem, well, you are inviting trouble. Okay? So then, I'll see you in the next class. Take care. God bless you all. Bye-bye.